feel like a little bit of a fraud today because I'm actually I was trained as an ancient historian, and I'm primarily an archaeologist, and about half of the talk that I'm going to give is about paleoecology. I've had a couple of frantic phone calls with our paleoecologist the last few days saying, you know, am I going to embarrass myself with this talk? And he assures me that that only at a few places I might do that. And I will, a lot of what I'm going to talk about is controversial. I'll try to point out the parts that are. But basically what I'm going to try to do today is talk about the long-term human impact on large-scale ecosystems and perhaps even the Earth system. In a way, to echo something that Jan said yesterday, this is the sort of case for the prosecution for an early an early Anthropocene or a Paleoanthropocene, and you can see what you. I was actually fairly ambivalent about this before I started. I am more convinced now. You can see what you think. So, just for my title slide, what I've done is put up. This is a land use or land cover map of the world, a recent one that shows that today about 40% of the world is dedicated to agriculture. 11% of that is for farming. The other 30% is related to pastoralism, and this global impact, the footprint of humanity is clear, quite large. And this is the agricultural sector is the second largest producer of greenhouse gases. The question that I'm going to pose, or the story that I'm going to talk about today, is how far back does this kind of global impact of agriculture and even some pre-agricultural subsistence systems have, and to what extent did those pre-modern subsistence systems affect large ecosystems and perhaps even the entire Earth system? So here's just a zoom in on Europe. And I'm going to start a little bit, I thought a good way to introduce this would be to talk about our own project, because we look at regional scale things. And I want to see, in a way, if our work feeds into this debate or can learn from it and might be a little regional piece of a mosaic to a larger picture. So we work in Bulgaria. Those are the Starplanina Mountains. In a landscape that looks something like this. This landscape, if you were just looking at it, say this picture, looks like, you know, it's not immediately apparent looking at that this is an entirely artificial landscape. There's, you know, with probably not even the exception of the high alpine region, that this landscape is entirely artificial. It is also about 3,000 years old and has changed surprisingly little in the last 3,000 years. So this is another shot of our other area that's actually study area that's actually somewhat closer to where our paleoecological work is. Again, an entirely if you'd you know, it's hard to even say what a natural landscape is here, because human impact and the larger scale ecological changes of the transition out of the last ice age were so intertwined with one another. But if you'd stood here, say, about 6,000, 7,000 years ago, you would have seen dense oak forest on this in this area. So. Our project, we're a landscape archaeology project. We map human use of the landscape, living on the landscape over long periods of time. This is the glamour of archaeology. We walk around agricultural fields, picking up crummy pot shards like this and counting them. So some of the pot shards are a little bit better. Sometimes we even get some nice burial mounds like that one. Some other features of the last few thousand years of human settlement. And we produce maps like this. That sort of this is our beginning stage, is producing maps of where people lived. And a little later, I'll show you some of the other things that we do about how people lived. So the other half of our project, in addition to looking at how people have lived on this landscape over the past 7,000 years or so, is a study of the past environment. This is a large gravel quarry in what used to be the largest, before it was drained in the early 20th century, the largest inland lake in the Balkans. It also had the advantage of being a lowland site instead of up in the mountains, which is kind of rare for a paleoecological site. These sites preserve records of past vegetation in the form of pollen, and we did our paleoecologist did a study of the pollen. Nothing much that the only thing I put this slide up there is to show we've got about a 5-meter record that goes back about 35,000 years from this site, and this is what the typical output of paleoecology looks like. This is a pollen diagram. This is what kind of pollen fell in this, in this area into this wetland area. It was a large lake and wetland area over the past few thousand years. And there's not much that this looks complicated. You can ignore most of it, but the parts that I will point out to you are this quercus. This is oak forest, and how oak forest increases from into the last ice age, and then it collapses. And this is a related core, but one that's a little bit. You can see this collapse in oak forest, and at the same time, you can also. This is a measure. This black area. This is a measure of burning. And this faint dotted line that you see here is a measure of erosion. And basically, when we put all this together, we see that this region, it was peopled pretty much as soon as the climate was capable of supporting agriculture about 8,000 years ago. And people moved in with the oak forests here. And for several thousand years, they actually, there's agricultural communities living in these oak forests that actually they practice quite intensive farming, and they only take up about 2% of the surface area of the 6,000 square kilometers that is the Thracian plain, the agricultural area that this is located in. So what happens for reasons that we don't really understand yet, and others don't really understand yet, between about 4,000 and 3,000 years ago, the agropastoral system, the subsistence system, the economic system here changed, and approximately the same number of people living there changed the way that they lived and deforested the entire area. And over the course of about a millennium, you get the area, get what our paleoecologists characterizes as pretty much 100% deforestation in the lowland accessible areas. So this again, this landscape is completely, artificial. I think I've got all of those points already. So major agropastoral change after about 4,000 years ago with near total deforestation. Interestingly, though, one of the things that has come out of Mediterranean archaeology over the last 20, 30 years is that we shouldn't always associate change with degradation. That despite the fact that there was this major change from a forested landscape to an open landscape by human agency, this area has, over the last 3,000 years, not only has the environment stayed relatively stable, but it remains a very productive agricultural area. So now what we want to do is, if we consider what happened in this one 6,000 square kilometer area that we've got a pretty good handle on now, what happens when we scale that? When we scale that up to first continental and then to global scales? This is a map from Kaplan 2009, which is one of the I think one of the more realistic models of deforestation. Starts in this goes from 1000 BC to 1850, and as you can see, even very early, deforestation is quite extensive around Europe, and there are a lot of these. There are a lot of other paleoecological studies that are rather similar to ours, that go from Central Europe, from Scandinavia, from all over Europe. And when you put those all together, this is based on a model, but when you put those all together, they seem to add up to major deforestation around and the introduction of agriculture and pastoralism to Europe very early. And if you zoom out even more to the whole and apply this to the whole world, and this is just this, don't worry about looking at every single one, but starting 8,000 years ago down to the immediate pre-industrial period, you could see the extent of global deforestation. Estimates are the best estimates right now are that by about 2,000 years ago, so we're at 40% of the world's land is used for agriculture today. By 2,000 years ago, it was already about 10% of the global land area was dedicated to agriculture. By 150 years ago, and 2,000 years ago, world population, all right, this is a crapshoot. This could be off by, it could be double or half easily, was maybe a third of a billion, 300 million people, something like that, using 10% of the Earth's land area to support them. 150 years ago, so immediate pre-industrial, 20% of the global land area is dedicated to agriculture, supporting a population of maybe 1.2 billion people. Today we've got 7.3 billion people using about 40%. So there's the relationship between population and the land area being used isn't linear. Land use has become generally more intensive over time, so that those population figures are going up rather faster than the percentage of land area dedicated to agriculture, even though in many cases the most productive land was occupied relatively early, at least before, say, 2,000 years ago. That's not always the case, and our own study shows that this isn't universal. That in our area we went from a very intensive agro-pastoral system that extracted as much as it could out of a very small area and produced very long-lived settlements that made these big, what they're called tells, or settlement mounds, from people living in the same place for thousands and thousands of years. That actually changes to a more extensive one where those permanent villages disappear, people become more mobile and use a lot larger area. So it's not universal, there are exceptions to it, but in general, agriculture becomes more intensive over time. And eventually, it reaches in the pre-industrial period about 20% of land area. So this is where things get interesting. This clearly, and I mean, we can see it where we work, and you can get dozens, hundreds, thousands of paleoecological studies from around the world showing how regional level ecosystems are dramatically impacted by agriculture. The question is, does this, when you multiply that over 10% of the 10 to 20% of the world's surface, does it produce some kind of an impact on the global system? And there's the Rudiman thesis. Rudiman proposed this first in 2003. Is that yes, it does, and it does that because this conversion of land that is mostly forested or more closed types of surface cover, more closed types of vegetation, and largely forest, when it is cleared, it releases a lot of carbon. So this is a series of maps like the one you just saw that looks at carbon loss in kilograms per square meter over time, and it ends up being significant enough, according to Rudiman and the others who follow him. And I will say this is. This carbon release isn't necessarily, this is maybe not too controversial, but everything that comes after this is pretty controversial. What Rudiman essentially argues in 2003 is that you've got this pre-industrial tortoise that precedes the industrial hare, and this tortoise is, the release of carbon and methane as well. Carbon dioxide from deforestation, methane from wet rice farming mostly, starting as much as 8,000 years ago for the CO2 and 5,000 years ago for the methane. It's the inputs into the global system are small every year, but you've got 8,000 years to work with, so eventually they add up. Based on, that's input to the system, and Rudiman thinks that he can see the response of see this in global greenhouse gas records and in temperature changes. So these are CO2 and methane, and they deviate. This is based on paleoclimatology. They deviate from the averages and the standard deviation of these averages for the last 4 interglacials. So basically, what he's doing is first mapping greenhouse gases, and in a minute you'll see he maps temperature then on how did their system behave in the last 4 interglacials compared to this one, and he sees an anomaly in the current interglacial that doesn't have a natural explanation. This is where it gets more controversial. Other climate scientists have said no, that this interglacial is different for natural reasons, and this is a heated and ongoing debate that I'd be happy if any of the climatologists or paleoecologists in here would geologists would like to talk about afterwards. So. By about 3,000 years ago, BP's before present, 3,000 years ago, you've got 7 part per million. 150 years ago, 25 part per million increase in CO2 that produces changes in global climate. And the bottom line with this, from the figures from 2005, these numbers I took from his most recent publication in 2014, are that there was about 0.9 to 1.5 degrees Celsius of pre-industrial warming, partly offset by the fact that when you clear forests and turn them into farmland, the albedo goes up, more light is reflected off the surface, so this offset the warming somewhat. But you still get 0.7 to 1.2 degrees Celsius of pre-industrial warming from these activities. He goes, and again, that's controversial. The thing that's even more controversial beyond that is that his theory goes on to say that without that warming, and this is partly, he's published a series of articles, some of which are based on what should have happened compared to the last 4 interglacials, and some are based on climate. So that's based on paleoclimatology, and then others that are based on actually using the computer models that are commonly used by climate modelers. And he claims that he gets an effect where without this warming, we would already be entering and would have already entered the beginnings of the next glacial phase, and that it has been it's been the warming produced by pre-industrial greenhouse gas emissions from the conversion of land, primarily from forests to pasture land and to agriculture, that have produced this warming that has essentially created the Holocene. That the Holocene has been warmer and more stable in climate because of the inputs of early agriculturalists. And he compares this to he says that it roughly, the range is wider, but that we can roughly double industrial, that we should double the figure for anthropogenic warming from the roughly 0.85 Celsius industrial warming. We should about double that to account for pre-industrial warming. So this, however, agriculture, however, is not the entire story. more and more examinations are coming out that look at foraging communities and the way that foraging communities interact with their landscape, and in fact produce landscapes. The old idea that foragers have a very low impact on their environment is not really. It's been superseded in the last 20 or 30 years, especially. One example of this, I'll ignore the case from Jordan right now, but on the west coast of the United States, this is where I'm from, I know some of the ecosystems that they're talking about here, that the indigenous populations of the west coast of the United States, although they were foraging rather than agricultural populations, opened up forests through burning, mostly, to produce prairies, to produce grassland that attracted the kind of game that they wanted. And there's multi-proxy evidence. There's a lot of evidence, whether it's evidence. If you look at trees that are still standing, that are 1,000 years old or 2,000 years old now, they show in their rings burning every 7 to 14 years, whereas the natural burn rate here, there's not much lightning on the west coast of the United States. There aren't, and it's quite a wet environment for much of the year, although it has dry summers. But the natural burn rate's only about once every 100 years, and it's being burned about once every 7 to 14 years. And this runs in studies all the way from the San Francisco Bay Area up to the Puget Sound. And there's also pollen studies, other studies like that show this kind of impact. And of course, probably the most dramatic example of this, and again, I'm a Mediterranean archaeologist, so I'm only going to describe the outcomes of some of this research. But Gamage's book, The Biggest Estate on Earth, about indigenous Australian land management practices, I think is really really one of the works, and put into the context of other books going back over half a century, other scholarship going back over half a century, at the way that indigenous Australians engineered ecosystems and produced a mosaic, essentially, of through the selective use of fire or prevention of fire, produce a mosaic of little micro biomes or microecological systems that they can rotate through to gather what they need over the course of years, decades, and accommodate. This is apparently a very old system, and it can accommodate the erratic climate in Australia, and indeed seems to have accommodated changes from the Pleistocene to the Holocene and other large scale changes. But this is it's done at a very, and this is something when we get back to Mediterranean archaeology, something that I know that resonates with me. It's done at a very local level, following practices. The practices seem to be continent-wide, like the idea that we are going to cultivate an ecosystem essentially in this kind of rotating productive mosaic that's the outcome of it, but actually implementing that is quite a local phenomenon. So the bottom line with this is that foragers also dramatically impact large ecosystems, and in fact, on a per capita basis, there are often population densities in agriculture. Even the earliest agricultural communities maybe have 10, 20 times the population densities that foraging societies do. But the foraging societies apply these techniques over even larger areas, on a per capita basis than the agricultural societies do. It's a little less clear whether this produces, say, a net impact on greenhouse gas emissions, because it's, if you're taking like on the west coast of the United States, Douglas fir forests and burning it out, and Douglas firs don't respond well to fire, it kills them. If you're burning those out and producing prairies, then it's likely that that may have a net carbon contribution. If you're doing what's done in other places and just keeping sort of a shrub perennial undergrowth clear, like seems to have been happening on the east coast of the United States, it's less clear whether that would have a net contribution to greenhouse gases. But there's one other thing that we also need to look at, and this is getting beyond just the release of greenhouse gases, something else that's becoming very that's becoming clear. And this is something I've really learned about in research preparing for this presentation. So again, I am happy to take be corrected afterwards. But the extinction of megafauna, of large animals, that seems to accompany the human expansion around the world. And in this article, he presents, this is the sort of smoking gun for him. It's that any individual instance of megafaunal extinction, you can argue about, oh, was it climate change? Was it natural climate change? Was it human activity? But when you plot them all, there's a strange coincidence with the arrival of humans. Humans seem to have played a role, if not been the only cause in many cases of these extinctions of large animals. And on this left-hand chart are the black bars are species that have gone extinct, and the farther you go to the right, the bigger they are, the bigger the animals are. And you can see broken down by continent the number of large species that went extinct, and it's significant. And most of these graphs are from the time they take is the Pleistocene Holocene transition, 11,000 years ago, something like that. So it may underestimate Australian extinctions a little bit since they happened earlier. Dowdy 2015 argues that these extinctions of large animals not only had impacts on regional ecosystems. When you take out the biggest herbivore, these are mostly herbivores. If you take out the biggest herbivore, it affects the entire ecosystem down the chain from that. But she claims that this actually has changed dramatically the global system as far as nutrient cycling goes. And we're about to hear more about this, and I'm really interested to it. But this is a map of nutrient cycling, mostly about phosphorus and how much it's decreased. In this bottom map, the lighter colors are areas where it has decreased lots. The red is where it hasn't decreased quite as much. But if I just cut to her final conclusion is that the nutrient transfer by large terrestrial herbivores has gone down by 92% because of the megafaunal extinctions at the end of the Pleistocene, beginning of the Holocene. So if this holds, this is brand new. I happened to hit it in a New York Times write-up when I was preparing a couple of weeks ago, and I think I haven't been able to find any criticisms, or I haven't found the response to it yet because it is quite new. But the argument is that even at even 11,000 years ago, or these extinctions maybe take place from, let's call it 50,000 years ago to 10,000 years ago as people move around the world. Some of them are even more recent, have dramatic effects on the on the global system of nutrient cycling. So all of this, together has led some people, including I'm new at Macquarie, and I was pointed out to me yesterday. I'm very embarrassed. I did not know that Foley was here until I didn't pay attention to my bylines enough, and I'm looking forward to talking at some point, but have proposed the idea of the Paleoanthropocene. You've seen this chart already, that these pre-industrial impacts are significant enough that they warrant being included in the Anthropocene phenomenon, even though it still makes sense to separate them somehow from the acceleration that's happened since the Industrial Revolution. And there was another Anthropocene article refining this. Glickson doesn't have a nice chart for me to put up, but his basic argument is that we should divide the Anthropocene into 3 sections: the early, middle, and late. The early being essentially hominins who have the use of fire, so back to maybe Homo erectus 1.8 million years ago, up to the beginning of agriculture, then agriculture to industrialization, and then industrialization to the present. So there have been some suggestions along those lines. I think that's. I could go. I could go. I guess I will just. I'm almost out of time, so I will just wrap things up quickly with the other half of this equation, and the one that I actually probably feel more comfortable talking about is how do people live in these environments that are changing either naturally or because of their own activities. And it is surprising, as I alluded to earlier, that it's perhaps surprising how resilient a lot of these communities are. Whether we're talking about indigenous systems of land management in North America or in Australia, or something like Mediterranean peasant agriculture. People have been saying that the Mediterranean has been degraded ever since classical antiquity. It's all ruined, but still, it's one of the most productive. It's a very productive agricultural area when it is managed properly. There's been some really good ethnography work done on how people manage it and how important it is to have a deep local knowledge of where you're practicing agriculture, and have the freedom to, or the agency to act on that knowledge. Something that we see in the Mediterranean is that the farmers there, they don't run down the ecosystems unless external pressures are put on them. Excessive taxation, major disruptions or instability. These things will push them to focus on short-term gains instead of long-term stewardship of the land. But they know when they're doing this. The farmers there, they're unlike a lot of elite agricultural writings, either from antiquity or from the 19th or early 20th centuries. The people who live here, they're not stupid. They know what they're doing, and when there's not too much external pressure on them, they care for the land with long-term goals in mind. Thank you.